Welcome back to the channel. In the next few minutes, we're going to show you how to avoid wasting time and budget on bad experiments. Essentially, what I call the 7 deadly sins of incrementality testing. Now, essentially, why does this matter? Testing drives big budget and product decisions, especially in marketing. And usually, the wrong conclusions equals wasted money and missed opportunities. Actually, anyone working with testing, and in particular, anyone working with marketing analytics, we need our tests to be statistically valid and actionable. Now, we might ask, why do we care? We basically use incrementality testing to answer expensive questions. Should we spend more on YouTube? Should we spend more on TV? Which channel should we cut? Should we roll out a feature? And a bad test can cost you millions. So we want to make sure that we get the science right. Essentially, there are 7 sins of incrementality testing. Thou shalt not test without power. Thou shalt not declare the null without confidence intervals. Thou shalt not stop thy test early. Thou shalt not test many things without adjustments. Thou shalt not use pairwise t-tests when many variants exist. Thou shalt keep control and treatment pure. And thou shalt not peak without alpha spending. Now let's start with the first one. Thou shalt not test without power. Basically, power equals 1 minus beta. Essentially, it's a probability of detecting a true effect. You can see here, I've shown you the sample size formula for the difference in means. But essentially, when we're talking about statistical power, we are talking about, does my test have the ability to detect an effect that I want to measure? So you really need to know, A, what is your minimum detectable effect, i.e., what is the effect that what you're measuring, and after that you need to calculate power. And in the chart you can see that power varies based on sample size and based on the effect. There's basically two ways to increase power. You either increase your sample size or you detect a larger effect. It's easier to increase power by increasing your minimum detectable effect, but sometimes you need to do it with sample size. Now, word of caution, if you are running underpowered experiments, you are going to get yourself into trouble. You are there is a very meaningful probability that when the test says there is an effect, that effect in reality does not exist. So really be careful. Do not run tests, any type of tests, without proper statistical power. The second sin is, thou shalt not declare null without confidence intervals. And this is a personal pet peeve of mine. Confidence intervals are not difficult to calculate. Most testing software, most statistical packages will give you confidence intervals out of the box. It is really easy for people to get tricked into not showing confidence intervals. This is particularly true if your confidence interval includes 0. Now, if your confidence interval includes 0, there is information. Now, some marketing analysts, I've worked with some, don't like to give senior stakeholders confidence intervals. The idea being that senior stakeholders want certainty, so they don't want intervals, especially when the interval includes 0 and goes from negative to a positive effect. Now, you are hiding information from senior stakeholders, and that information should be given. If you run a test and the confidence interval is a lift of +5 to +20%, that's one set of information. If, on the other hand, you ran your test and your confidence interval is more between -5 and +10, that is another information that tells your stakeholder, you should tell your stakeholder, you are uncertain about the effect. There might be an effect or there might not be an effect. Hiding the confidence interval will give a false sense of security, which in most cases should not be given. The third sin is, thou shalt not stop thy test early. Now, This is very common in marketing. It's related with another sin of peaking, which we'll get to it. But essentially, some teams or some analysts, when they're running the test, once they reach significance, they decide we can stop early. The idea being we already have statistical significance, so why waste the time or the budget keep by keeping the tests running? Now, this is a mistake, and the reason this is a mistake is the test parameters, the sample size, the effects to be measured, all of that, the alphas and the betas were defined based on that duration. That's problem number one. Problem number two, and this is related with another sin, is that statistical significance will fluctuate as the test will go on. The more you go through the test and through the duration of the test, your statistical significance will stabilize in either statistical significant or not significant, but in the early stages it will fluctuate, which essentially means you might be stopping on a false positive. Fourth one is the fourth one is thou shalt not test many things without adjustment. And you need to be careful about making multiple comparisons. Most tests, especially the common hypothesis test, where you're testing a null hypothesis versus an alternate hypothesis, are pairwise tests. They are meant to test one thing against the other. When you're testing a lot of things, I related with sin number five, where you're testing many variants, or in this case, you're testing multiple KPIs, your probability of getting a false positive will increase. And the the basic intuition you need to have here is very simple. Every time you do a KPI, you compare that KPI, you are running a test, and every time you're running the test, there's a probability that you're going to make a mistake, you're going to get a false positive, and the more comparisons, the more time you open the box, that gets inflated. And let me give you a very simple example. You are given, let's compare orders. You are giving, let's compare sales. And the test was, does this marketing channel, does this campaign improve sales? And the result is negative. So then someone asks, well, what about sessions? And you go in, you take the exact same data, and you run the t-test again, and lo and behold, sessions is still not statistically significant. But you don't give up, and you start, okay, what about segment XYZ? If you do this multiple times, you will eventually find a positive result. You will eventually find a statistically significant result. This is called data dredging. You are literally digging, trying to find something. If you dig hard enough, you will find something. Now, there are ways to do this. There are corrections. There's the Bonferroni and or the FDR. There's the Bonferroni or the FDR corrections. There's also sequential testing, which can be used to mitigate this. But be careful that if you are doing naive tests, you might end up in this situation. Now, related with this is the fifth one. Thou shalt not use pairwise t-tests when many variants exist. As I said, most hypothesis testing is pairwise. You are comparing alternative A with alternative B, hence an A/B testing. If you have more variants, ABC or campaign 1, 2, and 3, or campaign 1 and 2 and no effect, then a regular t-test is a wrong test to do. Basically, you either use ANOVA or you use a regression to test all at once. For instance, GeoLift, the Metas library, when it's using multicell, which is kind of what we're talking about, it's going to use a regression underneath to give you the test results, because you're not comparing simply a control A with a test B. Anytime you have more than two variants, this is marketing, product analytics, any type of test, anytime you have more than two variants, you need to use ANOVA or regression to test it all at once. Now, sixth, thou shalt keep control and treatment pure. This should be fairly obvious. Sometimes it's not, i.e., do not let your treatment group, you and your control group, be contaminated. Now, you might say, well, sometimes that's easy, but let me give you a very concrete example of where things might get a little bit wrong. You have a test running where you're running tests with test and control on regions for prospects, and you're trying to test how those prospects will convert into new customers. Now, at the same time, a second team, without you being aware of, is also running tests on that same region, but they're testing conversion rates of new customers. Now, you're increasing the new customer pool, i.e., the effectiveness of your test is going to contaminate the second test. So, this sin sometimes creeps up in very insidious ways, but essentially make sure that your groups are not dirty. Use cross you need to randomize, you need to exclude cross exposed users, and sometimes this means that you cannot measure with enough power the effects that you want to measure, so you need to compromise. And finally, the seventh one is thou shalt not peak without alpha spending, and this is related with the third one. Essentially, peaking is checking, do I have statistical significance? It's very common in marketing where you marketing teams set up their A/B testing campaign A versus campaign B, and they keep checking: do I have statistical significance? Yes or no. Do I have statistical significance? Yes or no. Once they have it, then they're done, and they stop the test and they stop the budget. An alternative to this is that you set the test to run for 2 weeks, but senior management wants reporting every day. So every day you need to open the test and see what are the results of the test. Is it up or down? Now, every time you open the test, every time you open the box, you are running a hypothesis test. Every time you do that, you have a probability of a false positive, which means you need to adjust. This is what's called alpha spending. Now, the Bonferroni adjustment, FDR adjustment, sequential designs will let you peak responsibly, but you need to adjust. And the the most common naive way to adjust is you need to increase the level at which you consider something to be statistically significant or not. In a way that this means that the burden for you to accept statistical significance at the beginning of the test is way higher than at the end of the test to compensate. This is really easy to fall into. Most analytical teams will do this. Usually they're driven by stakeholders asking for metrics. If you need to do this, you need to adjust your tests. And essentially, the key takeaways from this is always plan for power, for minimum detectable effect. What metrics are you testing? What is your duration? Protect and adjust for the multiple looks and comparisons, and preserve clear randomization in order to avoid contamination. Always follow these 3 Ps to avoid most of the pitfalls. Thank you for watching, and if you are interested, I am running in March a course on media mix modeling and incrementality where I will cover in depth all of these concepts with very concrete examples. Bring your own data and we'll work through it live. I'll leave the link on the description, and also on the description I'll leave a 25% discount code for anyone who wants to pre-register. Thanks for watching.